Well, welcome back, ladies and gentlemen. Mr. Eicher here, and I'm just excited. I'm excited about two-way tables, Venn diagrams, and doing a little bit of probability. So we're on a probability unit on Khan Academy. We're in chapter 5 in our textbook. Two-way tables are really, really common on the AP exam. Venn diagrams are a helpful tool to help you answer probability questions, though I don't think I've ever seen a Venn diagram on the AP exam. They are definitely a helpful tool. So let's check out this first question. What is the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. Overall, 340 were homeowners, 310 were high school graduates, and 221 were both homeowners and high school graduates. We will let G be the event of selecting a graduate from this sample, and H be the event selecting a homeowner randomly from this sample. So question A, let's create a two-way table and a Venn diagram that displays the data. On the AP exam, you will most likely not be asked and given the hint like this, hey, make a two-way table to help you answer some probability questions that we have. They would just kind of jump right to asking you about B, C, and D. So I'd like to show you how to make a two-way table. We've seen two-way tables earlier in the class, but a two-way table is called a two-way table because you have two categorical variables. A Venn diagram is helpful because you could have more than two. You could have 3 or 4 or 5. That would be a lot of circles on a Venn diagram. But a two-way table is 2 because it's two categorical variables. One of the categorical variables is this, graduate or not. So like a yes or no. So I like to do it like this. I'm going to write graduate. And then below that, I'm going to have yes, no. That's one of my variables. The other categorical variable is homeowner or not. So I'll put that over here, homeowner. Yes, no. And then you can start seeing a table form. Go like that. And then we can fill in the, 9 cells. We're going to have a total here. We're going to have totals here. And fill in these 9 cells here based on the given information. So first, overall 340 were homeowners. So find the yes homeowner. All the way at the end, the total is 340. And then 310, so that's that number. 310 were high school graduates, so find the yes graduate, and then go down 310 down there in the total. And then finally, 221 were both and homeowners and high school graduates. So that would be yes graduate, yes homeowner, 221. The other number we know is this, 500 was the total. So that would be the total in the corner there, 500. Now, based on that table, you could fill in the rest. So fill in the rest, doing a little adding, subtracting. 340 plus what's 500? I think that would be 160. 310 plus what is 500? I think that would be 190. 221 plus what is 310? That would be a 70. Is that 89, I think? And then 89 plus what's 160? 80, what is that? 71. And then down the column, 71 plus what's 190? 119. Should work across the row. Yeah, there you go. So there's your two-way table. We can also display this as a Venn diagram. A Venn diagram is a different pictorial model. You'll see Venn diagrams quite a bit on Khan Academy assignments. So I want to make sure you know how to read a Venn and create a Venn diagram. So here's our Venn diagram. We have this rectangle. Everything inside this rectangle represents all of our observations, all of our people in this case, so 500 people inside this rectangle. And some of those people, we'll do a little circle here, some of those people are graduates. So this will be my G, my graduate. So all the graduates are inside that circle. All the non-graduates, didn't graduate high school, are outside the circle, but still inside the rectangle, but outside that circle. Now there are homeowners. So there are homeowners like that, but this is a problem. Do you see what the problem is? There are some graduates who are also homeowners. So if you can't be both, if you can't be a graduate and a homeowner, you'd have a Venn diagram like this. But really, you should have two circles that overlap like that because there are some homeowners that are also graduates, and that's that overlapping region in the center. Now, this is not drawn to scale. So just because, that's a D, just because that little sliver in the middle is so small, that doesn't mean there's not a lot of people in it. There might be a lot of people in it. But again, it's just a pictorial representation. So don't let the areas of the circles confuse you, or the area of the little slice in the center there. So I would recommend when you have a Venn diagram, this center part, this overlap, to start with that. So that would be this, 221 were both homeowners and high school graduates. So we would put, slide it in here, 221 were homeowners and high school graduates. Now here's the tricky part about Venn diagrams. If 340 were homeowners, everything in this circle has to add up to 340. So let me write something wrong. This would be wrong. This is wrong because that, like, how many are inside this circle? That's 221 plus 340. That's way too much. So that 340 really is the total inside the circle. So we need something. So what's that? 119 plus 221. And that equals 340. So everything inside that H now, that homeowner circle equals 340. And we have to do the same thing. This 310 were high school graduates. This is wrong. That would be graduates who are not homeowners because there's no overlap with homeowners. So we really want this to be the whole thing to add to 310. So that would be, what is that, 89. So 89 plus 221 equals our total homeowners, which is 310. So then we just have one last number. This space out here, not in the G circle, not in the H circle, we have all the people who are not graduates and not homeowners. So how many is that? Well, we had 500 total people. So we had 500. 89 of them are grads but don't own a home. 221 have both. And 119 are homeowners but not high school graduates. So if we add those, I believe we get 71. So that 71 represents, that 71 down there, represents, it's on the outside of both circles, and it represents 71 people don't own a home and they did not graduate high school. So that's a Venn diagram named after the creator John Venn. And you can see Venn diagrams that have multiple events, maybe graduate, homeowner, and I don't know, car owner or something like that. So you could have 3 circles. So everybody in here would be, they graduated high school, they own a home, and they own a car or something like that, whatever you want to talk about. But that's the benefit of Venn diagrams. You could have multiple events, more than just two, whereas a two-way table, you're kind of stuck at two, unless it's a three-dimensional two-way table. Oh, now we're talking. Okay, let's use these to answer some questions. So we have question number 1. Suppose we choose a member of the sample at random. Find the probability that the member is a high school graduate. So probability graduate, that's our notation. Capital P for probability. Capital G is the event graduate from high school. Probability they're a graduate. Well, how many graduates did we have? 310 out of 500. You can leave your answer like that. I actually probably prefer you leave your answer like that. But if you want to write it as a probability with a decimal, it would be 0.62. It gets kind of dangerous when you start writing percentages because students are notorious for miswriting decimals as percentages. So please do not write 0.62%. You'd have to move the decimal to the right 2 spots to get 62%. But that would be our answer. This work right here is required as showing work on the AP exam. And no, you don't have to simplify it. All your math teachers before this would have a heart attack and want you to divide by 10 at least. But you don't have to do that in AP Stats. This is an algebra course. It's not a math course. It's a statistics course. So next question, what's the probability that they're a high school graduate and owns a home? The notation for and is an upside down intersection symbol. This is called intersection. And it means and. So the overlap. So using the two-way table, the overlap that they are both would be 221 over the total of 500. Now, literally, this overlap, this intersection is literally right in here on the Venn diagram where the two circles overlap. That's kind of convenient, where they intersect. And then the last part is a high school graduate. So the probability they're a high school graduate or the symbol is a union sign or owns a home. Now, when we mean or in statistics, we don't mean exclusive, like one or the other, but not both. They could be both. So that's really important. When we say or in statistics, it could be both. So it really depends what you mean by or. So did you make an A or a B? That would be exclusive. You can't make an A and a B. It's either one or the other. But in this case, it's like, do you want to go to the beach or do you want to go to the movies? And you say, let's do both. Well, maybe beach is appropriate because movie theaters aren't open right now. Teardrop. But to answer this, probability high school graduate or owns a home. Well, let's see. The graduate would be, there are 310 out of 500 who are graduates. Or is addition, I should write that on here. That is a union sign, and it is an or. Plus homeowners, there were 340 homeowners out of 500. Now, if we stop there, our numerator is way too big. Something happened, something went wrong. What happened was that when we add this 310 and this 340, this 221 got double counted. It was counted as a homeowner and it was counted as a high school graduate. So we have to subtract the overlap. It's not that we don't care about the overlap. It's because we double counted it. We counted it within the 310 and within the 340. Now, another approach you could use is you could just say, well, if I want one or the other or both, you could just say like this one plus this one plus this one, and that would give you the answer. Or you could do the complement. The complement would be, if I want one or the other, then basically just do 500 minus 71, and that would be your numerator. So what would that be? 429, if I did that right? 429 out of 500. So again, you could write these as what would this be? 0. Uh-oh. Get my point in the right spot. 0.442. You could write it like that, but I definitely would prefer just leave it as an unsimplified fraction. Save your time. And then this one would be 0.858. But again, this is completely fine and satisfactory. Now this last one that we just did, D, this is called the general addition rule. When you have the probability of A or B, again, that little U there is not probability of AUB, but probability of A or B. That would be the probability of A plus the probability of B minus the probability of the overlap, because we don't want to double count anything. We want to count people only once, not double count them. So that's called the general addition rule. And that formula is provided on the formula sheet. So you don't have to memorize that, but I hope that as you do examples, you get an intuitive sense of how to calculate these and that you don't have to memorize a formula like this, but it is called the general addition rule. Some other notation I wanted to introduce you to is on E, find the probability of not G. That little symbol there is a negation sign, not G. And it's also known, it could also be written as probability of the complement of G. So that little C is the complement. The complement's kind of like the opposite. It's like just not that. So basically we're finding the probability of not G, which is not a graduate. So the probability someone is not a graduate is just the no column. So in this table, probability of not a graduate is 190 out of 500. 190 out of 500. And that would be 0.38. So, but again, you could leave it like that. So you'll see that notation in future lessons. So I wanted to give a little shout out right there. And then the last thing I'd like to do in this video is talk about compound events. Compound events. Not just selecting one person, but selecting more than one. So compound, not just a simple event, but a compound event. So suppose we select two different members of the sample at random. What is the probability they will both be homeowners? So you want the probability that you get an H, then an H without replacement. Both are homeowners. So really, to calculate this, we're going to have the probability that the first person we select is a homeowner. And then we have to calculate the probability that the second is a homeowner, provided that we just selected a homeowner, because we want them to be different homeowners. So the probability the first is a homeowner would be, let's see, homeowners, yes, homeowners, 340 out of 500. So that would be 340 out of 500. Then we're going to multiply that by, we're going to select another homeowner at random. But again, they're different people, different members of the sample. So after you pick that first one, this is basically saying without replacement, because we want different homeowners. So if you want a different, now you have 499 people left because you just selected one. He's gone. And you have 339. Now on one like this, I would multiply it out. 340 times 339 divided by 500. So let's see if I did that right. 340 divided by 500. We'll do it the other way. Times 339 divided by 499. Oh yeah, I did it right the first time. So that would equal, you can check my work, roughly, I'm going to round a little bit, 0.462. And that would be your answer on the AP exam. But you definitely have to show this work on the AP exam, not just the answer. Okay, and then the last question in this lesson we'll look at is letter H. What's the probability they both will be graduates and homeowners? Whoa. So we want the probability that both are graduate and homeowners. So we'd like to calculate the probability that the first is a graduate and homeowner times the probability the second is a graduate and homeowner, given that you just selected one, because we want them to be different members. So what's the probability you get graduate and homeowner? So coming up here, graduate and homeowner, that was the yes and the yes. So that's the green overlap we have at the top there in the Venn diagram, 221. So we have 221 over 500. And then you want another one, but it has to be a different person. Without replacement, you got one less person, 499, and you got 220. Multiplying that, you get 221 divided by 500 times 220 divided by 499. And I got this answer roughly 0.195. I kind of like 3 decimal places when doing probabilities, unless it's in scientific notation. But again, your answer would be that on the AP exam. But don't forget to include this work right here. Well, I think that's good for this lesson about two-way tables. We covered a lot of ground there. Really, two-way tables, with one good two-way table, we could probably cover most of probability. I could ask you probably like 15 questions, and that would be like the entire thing, this entire chapter of probability with just one question. But we'll keep it at this, that we did cover a lot of ground. Make sure you're familiar with two-way tables, Venn diagrams, and notation. And again, I thank you for making it this far through the video. Give me a thumbs up if you made it to the end of the video. Thanks for watching. See you next time.